Hey guys, welcome back. So today we're going to be talking about 3.4 graphing functions. So before we can just look at a graph and draw the line that it makes based off of the function, we're first going to learn how to do it by plugging in points. So in order to do that though, we need it in a certain format that allows us to plug in easily to solve for y. So we want it set up so that we have input values that we plug in to get our output values. Remember, input is x, output is y. So to start, solve the following equation for y. It's 8x plus y equals 2. So I need to get y by itself. What's happening to y? It's being added by a positive 8x. How do I get rid of a positive 8x? Subtract 8x. What do I do to one side? Do to the other. Gone over here. That leaves me with y equals negative 8x plus 2. Mr. Door, why didn't you just write it as 2 minus 8x? When we get into slope-intercept form and all these ways of graphing equations from the equation itself without plugging in points, you're going to want to leave it as the x term first and then the constant. So let's just get in the habit of that now. On this one, we're going to have to do a little bit more. Still, the y is being multiplied by 10 and subtracted by 5x. And whenever we solve, we always look to add or subtract first. So, in order to get rid of the minus 5x, I'm going to add 5x. What I do to one side, got to do to the other. See how this all boils down to the same stuff we've been doing this whole time? So, now that's gone. I get 10y equals 5x plus 20. But I'm not done, because y still be multiplied by 10. Opposite of multiplying by 10, dividing by 10. What I do to one side, gotta do it to the other. And we do it to everything. So that gets me y equals 5 divided by 10 is 1/2 x. 20 divided by 10 is 2. So my final answer is y equals 1/2 x plus 2. That's how I'd get y by itself. Now let's go ahead and do that for these. And that's going to allow us to then plug in these points in order to graph our function. So first I'm going to add 2x to both sides. Oops. So that's gone. I get 4y equals 2x plus 4. Y is being multiplied by 4. Opposite of multiplied by 4 is divided by 4. What I do to one side, do to the other. So I get y equals 1/2 x plus 1. Because again, 2 divided by 4 is 1/2. 4 divided by 4 is 1. Now that's my input. Oops. Remember, this is my input. This is my output. So I'm going to plug my domain values, these, all my x values in for x as my input to get out my y put, which is y. So that when I'm done, I'm going to have ordered pairs x, comma, y. Plug in x, get out y. Because remember, domain is x. So I'm going to plug in x. So I get y equals 1/2 times negative 8 plus 4. Y equals half of negative 8 is negative 4 plus 4, which is 0. So when I plug in x, which is negative 8, I get 0 for y. When x is negative 8, y is 0. So my ordered pair for that one is negative 8, comma 0. X, y. Input, output. Alright, let's do it again for negative 4. Y equals 1/2 times negative 4 plus 4. I do the same thing. Y equals half of negative 4 is negative 2 plus 4. y equals 2. When x is negative 4, y is 2. When x is negative 4, y is positive 2. So that's my other ordered pair. Do that again. Y equals 1/2 times 0 plus 4. Y equals 0 plus 4. Y equals 4. So my ordered pair is 0, 4. My last one, y equals 1/2. Nope, not my last one. Y equals 1/2, 4 plus 4. Half of 4 is 2 plus 4. Y equals 6. So I ordered pair of that one. When I plug in 4, I get 6 for y. Last one, I'll put it here. Last one, I go y equals 1/2 times 8 plus 4. Y equals half of 8 is 4 plus 4, which is 8. So my ordered pair for that one, when x is 8, y is 8. And now I need to graph this. So, move this all over. So let's set up my graph. Mr. It looks like a lot of work on here. Yeah, it is. It's a lot of plugging in. However, on your work, you do not need to show every single one of these steps. Show me that you plugged in -8 and show me the ordered pair. That's going to be good enough for me. Because a lot of this you can definitely just do with a calculator. Which, speaking of that, we'll see who actually watches this video. If you bring in a calculator when I come back, which hopefully is Wednesday, it will be extra credit. Don't spoil it and give it all away. Don't say it in front of the entire class. If you watch this video, you deserve it. And I'm going to show you how to do this very efficiently on your calculator. Alright, let's go ahead and graph. So my ordered pairs are -8, 0, 0, 4, 8, 8, -4, 2, 4, 6. So -8, 0, -8, 0 is 1 point, -4, 2 is another point, 0, 4 is a point, 4, 6 is a point. And 8, 8 is a point. So around there. And look at that. If we did it correctly, should form a pretty good line. Now mine's not perfect, but if it's not, just make those dots bigger and it's great. Look at that. Perfect. And there's my graph. Mr. Door, is it really all that for just one problem? Yes, it is. Alright, let's take a look at another one. Solve this one for y. Oops, here we go. Here we go. Alright. Y is being added by 3x and multiplied by 2. So I'm going to subtract 3x. What I do to one side, gotta do it to the other. Here it's gone. I get -3x minus 6 equals 2y. Y is being multiplied by 2, so I divide by 2. What I do to one side, do to the other. So I get -3 halves x minus 3 equals y. I'm going to rewrite that. So y equals -3 halves x minus 3, just so y is on the left side. All right, we're going to do the same thing, plug in these numbers. So I go y equals negative 3 halves times negative 6 minus 3. Y equals negative 6 times 3, negative 6 times negative 3, I apologize, is positive 18 divided by 2 is 9 minus 3, y equals 6. So my ordered pair is going to be negative 6, 6. Next one, y equals negative 3 halves times negative 3 minus 3. Y equals negative 3 times negative 3 is 9. Divided by 2 is 4.5. 4.5 minus 3 is 1.5. We got a decimal. That's okay. So I get negative 3, 1.5. Y equals negative 3 halves times 0 minus 3. Y equals 0 minus 3, which is negative 3. So y equals, oops, not y equals. So my ordered pair is going to be, when I plug in 0, I get negative 3. Next one, y equals negative 3 halves times 3 minus 3. Y equals negative 3 times 3 is negative 9 divided by 2, which is negative 4.5, minus 3, which is negative 7.5. So when I plug that in, when I plug in 3, I get negative 7.5. And last one, y equals negative 3 halves times 6 minus 3. Y equals negative 3 times 6 is negative 18 divided by 2, which is negative 9 minus 3, which is negative 12. So when I plug in 6, I get out negative 12. Let's go ahead and graph these. Isn't notability amazing? So my ordered pairs are negative 6, 6, 0, 3, 3, negative 7.5, 6, negative 12. Oh, yeah, I thought I forgot. Alright, so negative 6, 6. Right up there, good enough. Negative 3, 1.5, 3, 1.5, somewhere in there. 0, negative 3, somewhere. Maybe that's too big. Somewhere in there. 3, negative 7.5. Yep, there we go. And 6, negative 12. So we're clear down there. And again, if we did it right, which looks like I was pretty close anyway. Oh, even better than last time. Let's go. There's my line. So again, for work you need to show on this, I should at least see you plug this in, and I should get that. That I solve, and I should see you solving for y as well. Should see all this. Should see this and this to get this. Show me what you plugged in. Show me what you plugged in. Plugged in. Plugged in. So yeah, there's gonna be a lot of work on these. All right. So that's same type of thing in C and D. If we were in class, I would have you try those examples on your own. Luckily with these, they get a little simpler because we don't need to solve for y because the function's already solved for. Remember, f of x is really just y. Mr. or why do we call it f of x? Why don't we just call it just y? Well, that's just notation because eventually what we're going to get into is you're going to say function evaluated at negative 6 And we don't want to write that all out, so we just say f of negative 6. So graphic function for the given domain. So more of the same stuff we were just doing. Oops. Alright, don't know why I did that. So this one, f of negative 6 equals negative 2 times negative 6 plus 3. Which equals 12 plus 3, which equals 15. So f of negative 6 equals 15. In other words, when x is negative 6, y is 15. So it's negative 6, 15 from an ordered pair. Do the same thing here. F of negative 2 equals negative 2 times negative 2 plus 3. F of negative 2 equals negative 2 times negative 2 is 4 plus 3, which is 7. So f of negative 2 equals 7. In other words, when x is negative 2, y is 7. In other words, the ordered pair is negative 2, 7. F of 0 equals negative 2 times 0 plus 3. F of 0 is going to equal 0 plus 3 is 3, so the ordered pair is 0, 3. Last one, f of 3 equals negative 2 times 3 plus 3. So f of 3 equals negative 6 plus 3 is negative 3. So it's 3, negative 3. And then we graph those. Alright, so I get negative 6, 15. Oh boy, that's going to be really high. Let's start here. Clear up there. 0 or negative 2, 7. So right around there. 0, 3. Somewhere in there. 3, negative 3. Somewhere in there. And again, if I did it right, I'd get a line. Pretty close. Pretty close. We're going to call that good enough. And there's my graph. And go ahead and do the same things with these. Remember, on this one you're going to square x first before you add 3. In this one you take the absolute value. So that's going to be, when you plug in negative 3, that's going to turn into positive 3 minus 2. So that one's going to be negative 3. When you plug in negative 3, you're going to get positive 3 minus 2, which is 1. When I plug in negative 1, that's going to be positive 1. So when I plug in negative 1, I'm going to get positive 1. Take the opposite value. Opposite values are always positive. So 1 minus 2 is negative 1. When I plug in 0, absolute value is 0. Absolute value of 0 is 0. Minus 2 is negative 2. And this one, absolute value of 2 is 2. So 2 minus 2 is 0. So there's my ordered pairs for that one. Alright. These. The only difference with these is they don't give you a domain. If they don't give you a domain, best one to use is going to be negative 2, negative 1, 0, 1, 2. So on your test, they'll give you something very similar to this. and it won't give you a domain. You're going to say, what do I plug in? Remember, I told you right here, use -2, -1, 0, 1, 2. 9 times out of 10, that's a very good set of numbers to use. So just these are the exact same. You just come up with your own domain. Alright, so give that a shot. See how 3.4 goes. Hopefully, I will see you guys tomorrow. Have a good one.